It starts like any other day. Clouds drifting across the sky, birds singing, people going about their lives. And then something changes. A bright light flashes in the upper atmosphere, brighter than the sun. A rumble builds beneath your feet. Seconds later, a deafening roar, followed by a shockwave that shatters glass, topples buildings, and sends people running for cover. This isn't science fiction. It's the real-world scenario that scientists use to model what would happen if a large asteroid struck Earth. But how bad would it be? Could we survive it? At Infinity Beyond, we're diving deep into the science of asteroid impact simulations to understand what such an event would truly look like and how we might prepare. Let's start with the numbers. If a 100-meter wide asteroid, roughly the size of a football field, were to impact Earth, it could release energy equivalent to 130 megatons of TNT. That's over 2,000 times more powerful than the atomic bomb dropped on Hiroshima. An asteroid this size would cause a regional devastation. If it hit land, it could flatten an entire city and start wildfires for hundreds of kilometers. If it landed in the ocean, the impact would generate tsunamis, large enough to flood coastal regions around the world. Now imagine a 500-meter asteroid. That's enough to cause continental destruction. The blast would generate intense heat, global shockwaves, and an injection of dust and aerosols into the atmosphere, potentially disrupting the climate for years. And then there's the catastrophic tier. An asteroid 1 kilometer wide or larger. This is the kind of impact that triggers mass extinction events. The last time something this size struck Earth was 66 million years ago, when a 10-kilometer asteroid hit the Yucatan Peninsula. The resulting Chicxulub crater was over 150 kilometers wide. The collision vaporized rock, triggered earthquakes, set the atmosphere on fire, and blocked sunlight for months. 3/4 of all life on Earth, including the dinosaurs, disappeared. So how close have we come recently? In 2019, Asteroid 2019 OK, a 130-meter rock passed Earth at a distance of just 70,000 kilometers, about 1/5 the distance to the Moon, and we didn't detect it until a day before it passed. That close call sent shockwaves through the scientific community. Since then, detection efforts have improved, but the fact remains, there are still thousands of near-Earth objects, NEOs, that remain untracked. What if we spot one too late? Scientists have modeled hundreds of possible impact scenarios using tools like NASA's Sentry system, ESA's Near-Earth Object Coordination Center, and Purdue University's Impact Earth Simulator. These models consider factors like size, speed, angle, composition, and location of impact. Here's how it might unfold. 1. Detection. Astronomers identify an asteroid on a collision course with Earth. If there's enough time, decades or years, we could attempt a deflection mission, as seen in Segment 10. But if the object is only detected weeks or days out, options are limited. 2. Impact location. Ocean impacts might cause tsunamis. Land impacts near cities would result in massive casualties. Even remote impacts could affect the climate and global economy. 3. Blast radius. Depending on size, a shockwave would spread out for hundreds of kilometers. Buildings would collapse. Fires would start. Emergency systems could be overwhelmed. 4. Aftermath. If the asteroid is large enough, it would inject dust into the stratosphere, block sunlight, and drop global temperatures, a scenario known as an impact winter. Crops would fail. Supply chains would collapse. It could take years to recover. So what are we doing about it? Fortunately, space agencies now take planetary defense seriously. Programs like ODART or NEO-Surveyor, and international working groups like IAW and SMPEG are coordinating strategies. But time is everything. The more time we have, the more likely we can stop the impact or prepare for it. Civil defense is also crucial. Cities around the world are starting to build asteroid impact response plans, including evacuation zones, tsunami protocols, and communication strategies. It's not enough to leave this to astronomers. We all must be ready. Because while these scenarios sound terrifying, they also highlight a rare truth. This is one global threat we can actually do something about. So, at Infinity Beyond, we explore the science not to scare, but to prepare. The universe is not out to get us, but it is unpredictable. The best way to survive a future impact is to understand the threat, respect the risk, and support the science that could save us. After all, the dinosaurs didn't have a space program. We do. Let's make it count.